In this two-part series, we want to look at taking word problems, solving them using systems of equations. Now, a few steps we need to make sure that we understand. Since we do have a system of two equations and two variables, you need to define your two variables. You're going to have to write two equations, and then of course you solve the system and state your answer. Now, all we're going to be focusing on right now will be setting up the system, because that should be the most difficult part. After that, you can use the elimination method or the substitution method to finish solving the system. Now, if we look at this first word problem, it says the sum of two numbers is 79 and their difference is 23. And then it wants to know what are the two numbers. Well, we're only dealing with two numbers. It's pretty basic, pretty simple. So we're going to define our variables like this. Let x equal just one of the numbers. There isn't anything more that we need to say about that. These numbers aren't representing anything special. And then we're going to let y equal simply the other number. Okay? So we have our two variables defined. X is one number and y is the other one. Now, going back to the word problem, we see that the sum of these two numbers is 79. So instantly we know that one of the equations is addition, and we are adding the first number and the other number, and it's supposed to equal 79. The other part says that the difference of those two numbers is 23. So difference, of course, means subtraction. So x minus y is going to equal 23. Now, the way this system is set up would be great for doing substitution, but it would be even better to solve it by using the elimination method. So you try that at home and see what you come up with. Now, this next problem is talking about a minor league ballpark. It says that it attracts 88 fans and draws in $553 in revenue from those ticket sales. Now, a child's ticket is going to cost $4 and an adult's ticket is $7. The problem is asking how many of each type of ticket were sold. Well, we have two types of tickets. We have ticket for a child and ticket for an adult. And what we can say here is this. We're looking for the number of adults and the number of children that came. That would tell us the number of tickets. We could use x and y, but let's try to use other letters. So suppose we let c equal the number of children, and then naturally we would let a equal the number of adults. We could use x and y, but I think by using c for children and a for adults, it makes things make more sense. Also, make sure that you use c, not ch or ad for adults. Your variable should just be single letters. Now, for a lot of these systems that we're going to run into with the word problems, there are two main types of equations. Contain one counting equation and one that deals with the value that goes along with each of those variables. In terms of counting, we know that we have a total of 88 fans. Well, those fans are made up of children and adults. So when we add the number of children and the number of adults, we come up with 88 people that saw the minor league ball club. Now, we have to somehow figure in the money. Okay, so this first equation just dealt with counting the number of people and the number of tickets. Well, how much money do we get from each child? Well, each child's ticket was $4, so we can say 4C. So 4 times the number of children will tell us how much money we took in revenue from just selling children's tickets. We add to that the money that we got from selling the adult tickets, $7 for each adult. And the total revenue was $553. So the first one deals with counting. The second equation deals with the value that goes along with each child and each adult. We come down here, we're going to solve it, and the answer should make sense. Remember, we're dealing with the number of children and the number of adults. No negatives, no decimals. We don't have parts of people going to see a ball game. Just doesn't happen. Also, we know that the number of children and the number of adults cannot exceed 88. When you add them, we have 88 people. So when you get the number of children and the number of adults, make sure that the sum is 88, and also make sure that the revenue would add up to be $553.